In today's session, we are going to learn about the particular solution of the differential equation. Hi, I'm Syed. Welcome to my channel Educate with Syed. Let's get started. The question is for the differential equation x plus y times of dy plus x minus y times of dx is equals to 0 and the condition y is equals to 1 when x is equals to 1. Find the particular solution satisfying the given condition. Let's try to rewrite this differential equation in the form of dy by dx. So I'll retain this x plus y into dy as it is. Send this x minus y on the other side, it becomes minus of x minus y times of dx. Now cross multiply the dx, we get dy by dx is equals to, or we multiply this minus sign inside, it becomes minus of x. You multiply this minus inside, it becomes minus of minus plus y. It is whole divided by. The denominator is x plus y. Or we can rewrite this as y minus x divided by x plus y. Suppose if I write the differential equation as dy by dx is equals to f of x comma y, then if we try to compare this one, so this function f of x comma y will be nothing but y minus of x divided by x plus y. So here we have the function f of x comma y is nothing but this one, y minus of x divided by x plus y. Now to show that this given function is a homogeneous function, we have to replace the value of x by lambda of x, y by lambda of y, and if you get lambda power of 0 into f of x comma y, then we say that the given function f of x comma y is a homogeneous function of degree 0 since the lambda power is 0. Now to show this one, let us put the value of x to be equals to lambda of x and y to be equals to lambda of y. So we get f of lambda x comma lambda y is equals to lambda y minus lambda x divided by lambda x plus lambda y. So what is common over here? Lambda is common, y minus of x whole divided by lambda is common, we get x plus y. We can cancel out this lambda and lambda, we are left out with y minus of x divided by x plus y, or I can rewrite this as f of lambda x comma lambda y is equals to, if you try to compare this one, is this not equals to the given function f of x comma y, right? So let us try to take this as f of x comma y, or can I write this as lambda power of 0 into f of x comma y. However, lambda power of 0 will be 1 itself. So now since you have got the function of this form, f of lambda x comma lambda y is equals to lambda power of 0 into f of x comma y. Here the function f of x comma y is a homogeneous function. It is a homogeneous function of degree 0. So if f of x comma y is a homogeneous function of degree 0, we can conclude that the differential equation, the given differential equation is a homogeneous differential equation. The differential equation is a homogeneous differential equation. So if it is a homogeneous differential equation, we need to solve this homogeneous differential equation. So we have the differential equation as dy by dx is equals to y minus of x divided by x plus y. How to solve this homogeneous differential equation? We have already seen in previous videos how to solve a homogeneous differential equation. So let us continue solving this homogeneous differential equation. Let us put the value of y to be equals to Vx. Let me take this as say equation number 1. Let me differentiate this y with respect to x. So then we get dy by dx is equals to, on the right hand side Vx is a product, therefore we are going to use the product rule. V as it is, differentiation of x will be 1, plus x as it is, differentiation of v with respect to x will be dv by dx, or rewriting this as v plus x into dv by dx. So let us substitute this value of dy by dx and y in this equation number 1. So equation number 1 implies, so dy by dx will now become v plus x times of dv by dx is equals to, we have y minus of x, y value is vx minus of x divided by x plus y value is vx. So what is common in the numerator and denominator? Is x common in the numerator? If x is common, we are left out with v minus of 1. In the denominator, what is common? X is common, we are left out with 1 plus v. We see that this x and x will cancel out. Now we can shift this plus v on the other side. So on the left hand side, we just have x into dv by dx is equals to, so this can be written as v minus of 1 divided by 1 plus v. Can I write that as v plus 1? Will it make any difference whether you write 1 plus v or v plus 1? I shift this v on the other side, it becomes minus of v. Now let us take the LCM as v plus 1. So this v minus of 1 will remain as it is, minus v times of, cross multiply it, you will be getting v plus 1. Or if we try to simplify this one, it is v minus of 1 minus, multiply v times of v will become v square. This is minus of plus will be minus, v times of 1 will be v, divided by the denominator we have v plus 1. However, we can see that plus v and minus of v will cancel out. And we see that both these terms are having negative sign. It's better we take that negative value outside. We are left out with 1 plus v square. It is whole divided by the denominator we have v plus 1. Let us try to separate this v values. Cross multiply, you will be getting v plus 1 divided by, now this 1 plus v square comes in the denominator, 1 plus v square. So on this side dv is being retained, minus sign will remain as it is, cross multiply that dx, it becomes dx by x. Now since they are in the variable separable form, you can just integrate on both the sides. Now let us try to split this one. It becomes integral of v is being divided by 1 plus v square times of it is dv. Again, since you are having 1 there, so plus 1 by, so you have 1 by 1 plus v square. So again you can apply the integral times of dv is equals to minus of integral of dx by x is nothing but log of mod x plus the constant of integration c. So we'll try to integrate this one by using the substitution method. So let us put the value of 1 plus v square to be equals to t. Let us try to differentiate this one with respect to v. So we get 1, the constant derivative will be 0, v square differentiation will be 2v, differentiation of t with respect to v will be dt by dv. Or you can keep v as it is, cross multiply, you will get dv is equals to, you can see that we have v into dv. Therefore here dt, cross multiply the 2 on the other side is divided by 2. So let us try to substitute this back over here in the given integral. We get v dv as dt by 2. it is whole divided by 1 plus v square is nothing but dt plus, now this particular integral is in the form of integral of 1 by 1 plus x square into dx. Its formula is nothing but tan inverse of x plus the constant c. You know this formula, right? Now let us try to use the formula over here. We get tan inverse of v is equals to, it is minus log of mod of x plus the constant of integration c. Here this 1 by 2, the constant outside, we are left out with integral of dt by t plus we have tan inverse of v. Let us take this negative log on the left hand side, it becomes positive, plus log of mod x is equals to c. This is half times of integral of dt by t is nothing but log of mod t plus we have tan inverse of v plus it is log of mod x is equals to c. Or if I use the property of logarithm over here, can I write this as log of t power of half, t power of half, this mod of t power of half, it is log m power of n can be written in the form of n log of m. So using that property, plus you have tan inverse of v plus it is log of mod x is equals to c. Let us take this as equation number 2. Now we need to replace the value of t. The value of t is nothing but 1 plus v square we have taken, and the value of v that we have, since we know the value of y to be equals to vx, so from here we can find out the value of v is equals to, so retaining this v as it is, cross multiply that x on the other side becomes y by x. So v value can be taken as y by x. So let us put the value over here. V value is nothing but y by x, but here v is there, so let us try to plug in over here. It is 1 plus v value is y by x, so it is y by x whole square. This is nothing but 1 plus we have y square by x square. So let us take the LCM as x square over here. If you take the LCM as x square and cross multiply, it becomes x square plus y square. So that's the value of t. So substitute this value back over here in equation number 2. So equation number 2 will imply log of x into t value is x square plus y square whole divided by x square to the power of half, to the power of half. Then plus we have tan inverse of v. V value is y by x is equals to the constant c. Or further if you try to simplify, it is log of mod x. This will be x square plus y square whole power of 1 by 2. It is whole divided by, this is square and to the power of half. So this 2 and 2 will get cancelled. It will just be left out with x plus we have tan inverse of y by x is equals to c. Further, can I cancel out this x and x over here? Then we will be left out with log of mod x square plus y square to the power of half plus tan inverse of y by x is equals to c. Or can I rewrite this value as half times of half, again I am taking outside, and log of x square plus y square. Since x square and y square both are positive, we can just write it as log of x square plus y square plus this value, it is tan inverse of y by x is equals to what we have is equals to c. Now let us take the LCM as 2 over here. We get log of x square plus y square plus it is 2 times of tan inverse of y by x is equals to c. Or I can rewrite this as log of x square plus y square plus it is 2 times of tan inverse of y by x is equals to, cross multiply the 2 on the other side becomes 2c. Now you can just replace this 2c by some other constant, say k. Then we get log of x square plus y square plus 2 times of tan inverse of y by x is equals to, I am replacing that by some constant. So therefore I am taking k to be equals to 2c. So let me take this as equation number 3. So what is given? Given that the value of y is equals to 1 when x is equals to 1. So we need to find out the particular solution. For that we have to evaluate this value of k by using this condition. So let us put x as 1, y as 1 in equation number 3. So equation number 3 implies log of x value is 1, 1 square is 1, y square 1 plus it is 2 tan inverse of x and y values both are 1 is equals to k. So we have log of 2 plus 2, it is just tan inverse of 1 is equals to k, or it is log of 2 plus 2 times of, what is tan inverse of 1? Tan inverse of 1 is nothing but pi by 4 is equals to k. So you can just cancel out this one, 2 1 times and 2 2 times. So therefore what will be the value of k now? K value will be nothing but this is log of 2 plus pi by 2. So you can substitute this value of k back over here in equation number 3. So therefore equation 3 becomes, so equation number 3 implies it is log of x square plus y square plus 2 times of tan inverse of y by x is equals to this k. K value is log of 2 plus pi by 2. So that is a particular solution of the given differential equation. So that's all I have for today. If you like my video, please subscribe to my channel. Thank you.